Hello everybody. Today we'll talk about how do we convert a 1/3 octave spectrum to a 1/1 octave spectrum. So to introduce, an octave band is a frequency band that spans one octave. Each octave band covers a specific range of frequencies. There are different types of octave bands, just 1/1 octave, 1/3 octave, 1/12, and so on. So the 1/1 octave band is like an entry-level octave band which provides lesser frequency resolution, and the higher octave bands such as 1/3, 1/6, 1/12, and so on provide higher resolution, but they also consume more data. So let's say you have like a higher resolution octave band and you wish to convert to a lower resolution. How do you go about it? Let's see that in detail. So let's say you have a 1/3 octave spectrum. You have captured the data, processed it, and you have this 1/3 octave spectrum. So on the y-axis is the sound pressure level in dBA, and on the x-axis you have this octave frequencies. Now I've chosen from 25 hertz to 20,000 hertz. There are frequencies beyond and below this, but they're out of the human hearing range, so I've just included these bands. So let's say this is the frequency band. Let's view it in a tabular form. So the same information, we are viewing it in a tabular form. So we have the frequencies from 25 hertz all the way up to 20,000, and these are the levels for each of those frequency bands. So as you can see here, octave 1/3 is a higher resolution frequency band, so you have a lot more frequencies. But when you look at octave 1/1, it has only 10 frequency bands because it offers lower frequency resolution. So you have from 31.5 to 16,000. But when you look here, you have like 25 to 20,000. So it provides 3 times more resolution than the octave 1/1. Now let's look at the frequency relations. We know that octave 1/1 has 10 frequency bands from 31.5 to 16,000. But octave 1/3 is higher resolution octave band. So as the name suggests, 1/3 is like splitting each octave 1/1 band to 3 equal parts. So for example, here we have 31.5 in octave 1/1, but in octave 1/3, the same 31.5 is split into 25, 31.5, and 40. So you get higher resolution. So you have more resolution. If you have just octave 1/1, you only see 31.5, but now here you can see even these frequencies. So this works for other higher resolutions as well. For example, octave 1/6, you're dividing each octave 1/1 to 6 equal parts. So with this idea, we can actually compute, actually convert a higher frequency resolution octave band to a lower frequency resolution. How do we go about it? It's simple. You just take these values, the sound pressure level for each of these frequencies, and add them up logarithmically to get the sound pressure level for this value. So you add them up logarithmically. The logarithmic equation is as shown here. So we have 3 values here, 25, 31.5, 40. Just plug in those sound pressure levels here, here, and here, and you get the final answer, which is a logarithmic addition of all these frequency bands. Now the same process can be repeated for each of those pairs of frequency bands. So after the logarithmic addition, we have the sound pressure level values for each of the octave 1/1 frequency bands from 31.5 to 16,000, which we can plot on a graph and view the octave 1/1 spectrum, which was calculated from the octave 1/3 spectrum. So you can repeat this process for higher resolution octave bands as well, such as 1/6, 1/12, 1/24. The only difference is the calculation time is going to exceed a lot because in this case, we just added 3 bands to get 1 band, but in case of octave 1/6, you're going to add 6 bands to get 1 band, and so on and so forth. All right, thank you for watching this video. I hope you enjoyed it. Have a great day.